All right. All of you got that, right? Now we'll do the regression. There will be so much more. Suddenly you'll be flooded with data. Don't get scared. There's nothing to be scared. We'll learn each one of those. But before that, I need to have data analysis plugged in. So add in Excel items analysis toolbar. Go to your data analysis toolbar. Go to regression and hit OK. It'll ask you for your input Y range. Select the Y. Remember, it's the house price column. It'll ask for the input X range. Select the X. Remember, I have the labels of the variables on top, so I'll say yes, I have labels. I'll tell me when all of you are there.
Input range was your house?
Yes, the house, it goes from A1 through A11.
Right. And your X is your...
B1 through B11. Or why I say B1? Because when I say B1, I have those letters in there, right? Those are not numbers, so I say yes, labels are in there. So I select or I check the labels option. Where do I want this? I want this in a new worksheet line. All right, I selected that. There are two other things I will select. Actually, three other things. Residual plots, the first two under residuals, and then a normal probability plot. I'll come to those. Why we need them, I'll explain that. So carefully look at what I have on the board. And I said, well, put it in a new worksheet line.
I see why.
All right. All of you got those selected, right? And hit OK. All right. This is what we have so far. Now I will explain what is what. I mean, this is very annoying, but I don't know why. The last two columns, the 95% confidence intervals, are repeated. See, the same thing is repeated twice. 232.78 minus 35.71. So you can delete these last two columns. I do control shift minus. No, control minus. My bad. Control minus. You can, I mean, you can forget it, but I get annoyed by it. I don't know why. There's too many numbers, so I don't need to look at it. All right. So all of you have this page, and I'll go through all of them, what you need to see from here. First, second, third, likewise, I mean, stepwise. So I said what we are trying to do is getting the best least squares estimates of this intercept term and this slope term, so that I have the best of line fit. All right? So the first thing is what is, the Excel has done this on the background. What is the beta 0, which is the best beta 0? So that's the intercept term. Do you see an intercept anywhere? Yes, the intercept is on line 17. The coefficient, I said the intercept coefficient, right? So the intercept coefficient beta B0 is 98.24833. And beta 1, which is the slope coefficient, the slope for what variable? The square feet, right? That's the slope coefficient. It's 0.109, blah, blah, blah. All right? So Excel has given you the straight line, where there is only one straight line in the whole world that these two numbers can plot. So it has given you the, assume that the green line is the best line. All right? Those two then are the beta 0 and beta 1. All right, what can you do with it? All right, your question, what can I do with it now?
You could graph the line of best fit.
You can grab the line of best fit, yes, we do that. I think I didn't choose that option, but you could do it. What Excel would do for you, it's already done here, so I could do what I said. So I have the house prices here and the square footage here. So if I plot the house, if I take these two, copy it, and put it on this cake. All right, I'll plot that for you in a second. Since you said, I'll plot it in a minute. But before that, so what does the intercept tell you? The interpretation of that is most important. You know the beta 0 is 98.24833. The beta is 109. So what is it telling you? That is my first question. What beta 0 tells us, it is the y-intercept term, right? So if your x is 0, what is the y? All right, hold on. A house whose square footage is 0, its value is 98.24. What does that mean?
It means that, well, you can't actually have a house with 0, 0. It needs
So the constant term is not necessarily has a meaning. Sometimes if the meaning of a 0x is meaningful, which is not in this case, then you could say if x is 0, y will be this. In this case, the beta 0 value has no meaning, but we still have it. The math says that is the best line of fit. When the beta 0 is 98.24, that is the best line of fit. It gives you the least squared error, sum of squared error, right? So if you check this out, you have this option in Excel when you did the regression. I'll select that data point again and I'll show you this. It says regression. It says constant is 0. Never, never, never choose that constant is 0. Then the math is all screwed up. You get wrong, biased estimates. Even if x0 has no meaning, you still need a coefficient for the intercept because that is the best way of estimating the best line. All right? It might not have any meaning. Another thing that I'll draw your attention to, the y variable said it's the price of the house in thousands of dollars. So this is actually $324,000, right? So beta 0 doesn't have any meaning, but beta 1 does have a lot of meaning. It tells you if the square footage of a house goes up by 1 more square foot, this is 0.101, so 1 more square foot. This is how much the value of the house is going to go up. But then remember, these are in thousands of dollars, right? So multiply the coefficient times 1,000, you get
109.
109 points, whatever you have, 768, right? Oh, I don't have it here, but 109.768. That's how much a house with 1 more square foot will increase the price of the house in your sample. Right? So that is the interpretation of beta. Once you know that, you can say, well, my house sizes are going from 1,100 square feet to 2,450 square feet. So what is the price of a house that is 2,000 square feet? Can you all try and tell me what that should be? How many of you can do it?
Repeat.
So if square footage is 2,000, what is price? Or the predicted price? Predicted has a hat. It's a hat, it's a thinking hat, we're thinking through this. So that's prediction, it's not the real price. Can you do that for me? Hmm?
You said just type in 2,000? Is that what you're saying?
No, I'm saying if this is what I told you, this is the regression. So I got the regression results from Excel, this is what I got. And I am asking you, you are the statistician or the analyst, and you are able to answer all my questions. What should be the price of a house, which is 2,000 square feet?
219,000.
298,000. How do you get it? It's very simple. All you need to do is add 98.248, which is in thousands of dollars, right? 24833 plus the slope is 0.109768 times 2,000 now. So y equals mx plus, so y is m, this is the x now, plus c or b, and everything is in thousands of dollars. So to get the real price, you multiply that by 1,000. Whatever that value comes to is what you get. So how would you calculate that? I can do that I can do it in two ways. Let me show you the harder one first, because this is first, it requires you to do the regression, the whole thing. Then I'll say, well, what is the value of house price when square foot is 2,000? I take the coefficient, the slope, sorry, the intercept first. Then I take the slope times 2,000, right? That is the value.
So you took the
So what?
intercept and
I added it's y equals mx plus b, exactly. So I added the b, which is the slope, the intercept, 98.24 plus beta 1 times 2,000. Exactly this calculation. That's what I did over here. It's 317,000, so it's in thousands of dollars. So if I need in actual dollar value, then I would multiply, because the house prices were, the y was in thousands of dollars, I need to actually multiply that with 1,000 to get the real price in dollar value. Why did you get 298 now? We want to learn from your mistake.
Maybe because we rounded up some.
Not that much.
Wait, what did you say?
He got 298 for some reason, I don't know why. All right, there is another way of doing this. Instead of going through and running the whole regression, there is a point we'll learn all these things, what are they used for, etc. But if you are just wanting to do a quick and dirty thing, you can do this. So predict regression. I thought it was too big. There's a command, if you don't mean easy, oh no, focus, not delete. Alright, similar words, right? Focus. your x value, in this case it's 2000, your known y's, which is your sample y's, that's this, that's your first array, second array, well, first array, first one is a value, second one is an array, the third is your known x's. And it should give you the same result, 317.784. 317.784. All right, so that is an easy, quick and easy way of doing the same thing. Excel is doing all this calculation in the background and doing that for you. So why so many other things? I mean, if we can predict this, why do we need all the other junk that you see over here? What do you think?
Why would we need all the other stuff?
So there is so much more information on this. I also got the plots of the normal, the normal residual plots. The plot, what do I have here? The first plot.
Well, you also have standard error and stuff like that.
I have standard errors and stuff like that, yes. I'll get into it. But I also have the residuals. What are the residuals? So once Excel does this calculation, it knows what's the beta 0 and what beta 1 is. It goes on and does exactly what I said, and this is where I come, Jonathan, where you asked, we can plot the line of best fit, right? So let me put this, of course. So this is my actual house price in my sample. This is the square footage, actual square footage of the houses. And then Excel will come up with the predicted values of the different observations. So it has the predicted values of observation 1. If I paste it here, these are the predicted values. It does the calculation for me. See that? It's already there in the output. So we said, well, we are doing two things. We have the actual plots, the dots, the scatter plot, which is the actual data. Then we plotted the straight line, which is our best line of fit from the regression. That's the green line. So that green line is basically this predicted Y, predicted house price. In thousands of dollars, of course. So if that is the case, you can for yourself calculate the residuals, right? How do you do that?
Minus.
This is nothing but whatever this value is minus of this. I can drag, right? And get all those values. So this is what it does with the residuals. Minus 43.17, the last one is 19.998. So 19.9928, 43.17. So now I can plot what Jonathan was asking. Insert scatter plot with 3 points. It doesn't do the straight lines. Excel doesn't do it, so I'll leave it like that. So predicted values is the straight line, the orange dots. The actual are the actual values of houses given the different square footages. All right, how does it look like? Does it look like a good fit? It does, right?
I have a question.
Yes.
You said you click shift, right? And then you can move stuff like that?
Mm-hmm.
I
I don't know, no, not
I
on
don't know
Mac.
if I'm doing something wrong.
Not on Mac, not on Mac. It's different on Mac.
Oh, wait, no, okay. I got it actually.
It did?
Yeah.
Okay. I don't know on Mac. I've never used it. So that's what what I have drawn over there, it's already there. Except the errors, you have to calculate it. I mean, it's the distance, vertical distances of each of those blue lines from the orange dots, right? Those are the residuals. So, you could do that. That is one thing you can do from the output. What else? Again, I said there are so many other things. So what are the other things? So the first things you look at for a regression, you start at the top. When you do a regression, multiple R is 0.76. Have you seen that number before?
No.
Yeah, it's the,
Correlation coefficient, right? It's on a percentage basis. It's 0.76. Oh, no. It's from 0 to 1. -1 to +1. This is 0.76. That's what you got. It's the correlation coefficient. All right? The R squared, that is now the next topic. All right. How about 10 minutes break? Yeah, I can let